Buddy, welcome back. So again, somebody asked me, and all these are genuine doubts, and I think I should address it. So they had this doubt that you know until now what we have studied the gravitational potential energy. So let's say this is the object, and we pick it up to a height h. We are writing the potential energy here to be mgh, correct? Where m is the mass, g is the acceleration due to gravity, and h is the height. But in previous videos, we have determined or we have derived an expression that gravitational potential energy is minus g, capital M mass of Earth, small m mass of the object divided by r. Yes, this is what we have derived. So I should write when this is sitting here, right? And when it is at a height h, I should use that formula to calculate it. Why are these two formulas different? And what is the change here, right? Why are we using two different formulas for the same quantity? So I'll tell you something. When we have, so let's say this is a cap, it has a mass m, it is at the surface of the earth. Surface of the earth means that it is at a radius r from the center, correct? When we are picking it up and moving up to a height h, this height h is very small, first of all, right? So whenever you are writing mgh, when you are using mgh, h is very small as compared to the radius of the earth. You are not moving 1,000 kilometers above, or you're not moving 500-600 kilometers above. Whenever you are deriving this mgh, you are by default assuming that acceleration due to gravity is constant, correct? So how are you doing mgh? You are saying that, okay, fine, the mg is acting downwards, the force is acting downward, displacement is upwards, so the work done by the gravity is minus mgh. Yes, and work done by the gravity is minus of change in potential energy, so that becomes potential energy at a height becomes mgh, right? So in this derivation, what you have done is you have considered mg to be constant, right? And you can consider mg to be constant if g is constant, which means that acceleration due to gravity has to be constant. And acceleration due to gravity is constant only if this height is very small, because if height is very large, the acceleration due to gravity varies with height, correct? So it varies with height, which would be again wrong. Right now, coming to the other part of the question, which is that if chalo, yeah, somebody said that fine, let's say I agree with you that g is not a constant, but then again the expression should come the same from the other formula also. Whatever we have derived, minus g capital M small m by r, from that also the expression should come the same, and it will come same. Let me tell you how. Let's say this is at the surface of the earth, and I'm writing the potential energy of this object here. What will I write? Since it is at the radius r from the center, I will write minus g capital M mass of earth, small m mass of the object divided by capital R, where r is the radius of the earth, correct? Now let's say I move it up a distance of h. Now what will I write the potential energy? Minus g capital M mass of earth, small m mass of the object. Now the distance from the center has become r plus h, because now we have moved a distance height of h. Now you again do the same thing. Now you again calculate the difference here and here. What will be the difference? I'll tell you. You can take, if you subtract both of these results, what will come? G capital M small m 1 upon, in the bracket, 1 upon r plus h minus 1 upon r. Now you do the LCM and subtract, you will get h in the denominator, right? Or basically you will get minus h in the denominator, and in minus h in the numerator, and in denominator you will get r into r plus h. Now you see h is very small as compared to the radius of the earth, correct? Radius of the earth is around 6,400 kilometers. H is nothing but maybe 5-6 kilometers, right? Maybe we are doing those experiments near the surface of the earth. So you can neglect h with respect to r. If you neglect h with respect to r, in the denominator you will see that r into r plus h will become r square, correct? And what do we have here? Just imagine it in your head. What do we have in the numerator? Minus g capital M small m h divided by r square. And what is g capital M by r square? G capital M by r square is nothing but the acceleration due to gravity. So you are again getting the same expression, which is minus mgh, correct? So work done by the gravity again is minus mgh here, which is the change in potential energy, correct? Or minus of change in potential energy, correct? So again, both of these formulas are same. Just for the convenience, we have derived it in a very easy manner, which is mgh. I hope these two concepts are clear. Please write it on the paper and do the derivation yourself. Then it will be more clearer in your head, right? Thank you so much. Have a very nice day. Bye bye and take care.